Hi, this is Professor Fernandez, and I am going to work on Class Notes B here in Lesson 8. The goal of this class notes is to show you what the elementary row operations are, and then to use them, illustrate them, to solve this linear system. So let's get started over here. So I'm going to take the linear system, I'm going to rewrite it over here, and then use this as an opportunity to illustrate these elementary row operations. Okay, so I'm going to just keep track of what the operations are that we're doing. So I'm going to call this step number 0, right? I just rewrote the problem. I haven't started solving it. So the first thing I want to do if I want to solve this for x and y is, what you probably already do anyway. You want to try to eliminate one of these variables, right? And you tend to do that by, maybe multiplying this row by something, or multiplying that row by something, or swapping the two rows. And that's effectively what elementary row operations do. So, first thing I'm going to, my eye is drawn toward here are these decimals, right? So I want to get rid of those just so that I can try to solve this system a little bit easier. So the first operation I'm going to do is I'm going to say the second row in this system, I'm going to replace it by, let's keep it simple. How about 10 times the second row? Okay, and that's going to give me, I did not change the first system, right? And then if I multiply 0.2 times 10, I just get 2. And if I multiply 0.4 times 10, I get 4. And then if I multiply 3 times 10, I get 30. Great. So that just makes my life a little easier. I'm not dealing with decimals anymore, so that's nice. And then I'm going to do another row operation. I see that 2, 4, and 30 have a common factor of 2 in them. So I'm going to replace row 2 with row 2 times 1/2. Okay, so I don't change the first row of the system, x plus y is 10, but I do change the second row. I'm basically dividing everything by 2. So the 2x becomes an x, the 4y becomes a 2y, and the 30 becomes a 15. Right? So you can see kind of how this is going to go now, right? I'm keeping track of the operation here on the left-hand side. And I'm using this arrow to tell you, whatever the row was that I had on the left-hand side, it is getting transformed into this new version of the row. Great. So now let's go back to solving the system. This is looking pretty good. And here I have x plus y. Here I have x plus 2y. It looks like I could eliminate the x's if I effectively subtract the two equations. So I'm going to do that now. I'm going to say row 2 is going to be replaced by row 2 minus row 1. Great. So I don't change the first row. There it is. Excuse me. And then what I'm doing is I'm taking this entire second row and I'm subtracting from it the first row. Okay. So if I do that, I'm going to say x minus x. That gives me no x. So I'm not going to write that. And then I'll say 2y minus y. That gives me y. So let's put that here. And then over here, I get 15 minus 10. That leaves me with 5. 5. So you can see how this has turned out to be very useful because I now know what the y value is. Okay, but just to keep, so I could substitute that y value in here and solve for x. But to continue illustrating row operations, right? I'm going to do one more row operation, and we'll see why I'm doing this in the next video. I have a y here, I have a y here, so I can eliminate the y from this first equation by doing a very similar row operation to what I just did. So I'm going to say replace row 1 with row 1 minus row 2. Okay, so x minus 0x, there is no x there, that does not change the x. But now the second part, the plus y, is going to change, right? So I have y minus y, right? Remember, I'm subtracting the second row from the first row. Great. So y minus y gives me 0y, right? So I'm 0y, so I'm not going to write that here. And then I have 10 minus 5, so that gives me 5. So I get x equals 5 for the first row. I did not change the second row in this step. So I get y equals 5. And, clearly this tells me that x and y are both 5. And that is the solution to this system. And, if you're in doubt, right, you could always go back and take that solution and substitute it in here. Make sure it satisfies it. Certainly 5 plus 5 is 10. 5 times 0.2 is 1. 5 times 0.4 is 2. And 1 plus 2 is 3. So indeed that satisfies that equation as well. So we have found the solution to the system. And to recap, what did we do, right? So we kind of formalized a process that you likely are already used to anyway for solving systems of linear equations. You take a row and you multiply it or divide it by a number. So this is going to be one row operation that we will define later in the notes. Or maybe you take a row and you combine it in some way with another row. This is going to be another row operation that we define. There's a third row operation which we didn't illustrate here, and that's swapping a row. So if I had started with this system up here, and for example I said, you know what, I want to just swap the first and second equations. So I want the bottom equation to be on top and the top equation to be at the bottom, right? Clearly that would not have affected the solution. I haven't changed anything. I just changed, where the equations go, which order they go in. Anyway, but that's another row operation. And we'll see a little bit later on as we continue doing, our introduction to linear algebra, that could actually help in some instances to make this process of solving the linear system a little easier. But anyhow, that's a preview of the 3 row operations, where they come from, how they're useful. And let me just scroll down here. In the next class notes, we will talk about augmented matrices. So I will show you how to do the same solution to the system we just solved, but using matrices. And then down here is when we actually are going to define row operations. So there's the interchange of 2 rows. Here is the multiply a row by some number, and here is combine in some way 2 rows, add, subtract, perhaps scaled to be the result of the original row. All right, so that's it for this video, and I'll see you in the next one.